Is it actually live? Oh shit, it's live. Okay. Ew. Ew, I don't like this quality. It's actually live. Okay. Okay. So. Oh shit, it's live. Okay. Ew. I will need probably 10 minutes to set it up. Quality. Okay. Okay. So. Oh shit, it's live. Okay. Ew. I will need probably 10 minutes to set it up. Quality. Okay. Okay. To see how the live actually goes, I look on the tablet in front of me. I will need probably 10 minutes to set it up. Oh, 3 watching. What? Okay. Okay. To see how the live actually goes, I look. Okay, it's not bad on the tablet in front of me. My voice is 3 watching. What? Oh no. Okay. My voice works. To see how the live actually goes. It's not bad. I feel like I'm listening twice to my own voice. My voice is 3 watching. What? Oh no. Okay. My voice works. Test. I feel like I'm listening twice to my own voice. My voice is... Why is there an echo to my voice? Test. Yeah, okay. How? Why? I should have made it private. Well, no. It should start in an hour, so come on, I've got time. Yeah, okay. How? Why? I should have made it private. Well, no. It should start in an hour, so come on, I've got time. Again, I'm listening to my own voice in... Give me some time, please. Dove dai? I have no clue. Give me some time, please. The echo might be from YouTube Studio in your browser because it is delayed. Yo, it's an actual person. Hi. Thank you. I will look into it. Please be patient. The echo might be from YouTube Studio in your browser. But right now, I'm only listening to the live from my tablet in here. It's an actual person. Hi. Thank you. I will look into it. Please be patient. So the only source I'm listening to right now is from the tablet. But let me see. I'm only listening to the live from my tablet in here. Yeah. The only source I'm listening to right now is from the tablet. Could it be that, yeah, desktop audio? I probably see the audio coming out my desktop audio. But what if I silence my desktop audio? I silenced my desktop audio. Yeah, it looks like I don't hear my voice anymore. Twice. Okay, so it's there the problem. Now, I can actually change the view so you don't only look at me. Yeah? Like this. It's not great. Advanced audio problems. Active. What if I set it to minus 90? Minus 99. No, I don't like that. Is it the maximum? Let me see. Why can I just deactivate? Okay, close. I probably fixed it because I took off the microphone from my webcam. Okay, close. I probably fixed it. I did because I took off the microphone from my webcam. Yeah, I don't hear my voice anymore 2 times. Great. Let's switch back. Fuck, I haven't fixed it. Fuck. Why? Yeah, I don't hear my voice anymore 2 times. Output. Great. Yeah. I heard it too, Tim. Fuck, I haven't fixed it. Fuck. Why? Output. Yeah. I heard it too, Tim. Let me see. No. Test. So I've got OBS. Test. And I connected OBS to YouTube Studio. I wish I understood what you meant.
So I've got OBS.
Oh, that was dumb. I was looking at my own live on my browser without realizing it. Yeah, it was just a dumb error. Yeah. Okay. Yeah. Okay, it's fixed. For sure. Alright. I can take this off. Lower my voice from the microphone. It's a bit too much. Okay. I can start. Well, I'm going to start way earlier, but it's because I don't think I can assemble entire mouse in only 5 hours, 6. I hope so. I hope it works. The first time I did a test assembling a mouse, I had to troubleshoot for probably 2 hours. So, yeah. So, since we've got only you, Tim, do you have any question, or I can just start with some things? In the meanwhile, I've got, I can show you the transparent one, which actually works. Okay, hearing my own voice twice, it's a bit unsettling. Okay. So, this is the transparent version of the mouse, with all the wires visible. It has no weight inside, just because it's cool to see all the wires. I made a black one, which I'm going to use as a reference right now to build. And I will probably disassemble this one because it fell and it broke. The compliant mechanism broke. There. Which this is going to be my reference one. And this one is the first one I've made, which works great, and it has the LED balls inside, so you can hear it, but still, it works fine. It works great. Now, 2 people actually got the digital files, which I wasn't ready to completely sell them, even though I made them available to buy, because there is no bill of materials, list of materials, and an electrical design. So let's start with this. Bill of materials. In the kit that I made on Etsy, which probably no one will buy, but it's fine, you will find 8 resistors. 8 resistors. Here we've got 10. Yeah, 10, because I'm gonna send more. Probably someone can break them. And the resistance of this, yeah, I'll just start. The resistance will be 4.7 million ohms. Copper wires, these need to at least be 0.6 millimeters in diameter, and this one, which is 0.1, it's let's say the and hard mode to create the mouse. Because if you are not really good at soldering, you should use this, the jumper wires. Then rubber feet. The dimension of these rubber feet are 8 by 3, I think. No, 10 by 3. Yep. And there are 15. Yep. M3 12mm screws. And how many of them? 12. Then USB-C to C extension, because the regular Arduino with USB-C, it's kind of flimsy, so if you keep connecting and disconnecting inside of this, it can just break after probably 20 times if you are not careful. Then you will find a circular LED. This one is RGB. I'll just open one. It has 12 LEDs, and the dimensions are external ring 50 millimeters. You can see it in the big screen, yeah, and internal 36. Then we've got the magnetometer, which is a GY273 HMC 5883L. One thing to remember is that it has to be HMC and not what was the other version? QMC. I don't really know the difference. A lot of them say that the one that they are selling it's HMC, but it's not. And the most reliable thing to be sure that it's an HMC, it's the shape. It's a rectangular, not a square. Because I found some people that even type on it that it's an HMC, but it's not. You won't need these extensions. Then we've got the gyroscope, which is a GY521 MPU6050. Nothing more to say about it. By the way, after the live, I will concentrate everything that I said important and make a video for those who do not want to see probably 7 hours of me stuttering and speaking. This is the MP. I don't know this. We've got the Arduino. It's an Arduino Pro Micro. It's a copy of Arduino Pro Micro, but that's fine. 5 volts, USB-C. Again, you won't need these extensions. Then these are the LED balls. Not still LED balls. I don't know if I'm gonna use them right now. We'll see. I put them aside. I've got the wrist rest, and I can explain you why it has so many holes. Because the idea is, for starters, we've got the main mouse, which has the holes on the back side, so it just stays here. And for the future, you can make your own wrist rest with these 3 holes, or I can sell you this digital model from to this wrist rest, which is made in PTG, and the top is in resin actually, because here, okay, it's in resin because I like it to be smooth. And the base is in PETG, and it works well. I've got it for probably 2 years. It did not break, and it works nicely. But that's a future project. Wrist rest. Oh, magnet. This is important because the sensitivity of the magnetometer depends a lot on the code, then on how you code the magnetometer, and obviously on the magnet. So this magnet, it's 8 by 3. Let me check. Yeah, 8 by 3. Yep, 8 by 3. And something important is that it has to be N52 certified. That's all I can say because I don't know more. Be sure that it's N52, which is the strength. I think it's a standard for magnet strengths. Put it here. Okay, physical parts. We've got the base. I took off all the supports, and that's it, nothing more to say. The cover, where inside will go the Arduino. The cap with a red north for the compliant mechanism. Now, this compliant mechanism, already I've removed the 3 custom supports, which I'm going to show you right now on this white one. This is from PCBWay. I had to be sure that the custom supports were going to print nicely. Why custom supports? Because regular supports will be impossible to remove without breaking the compliant mechanism, which obviously it can be easily broken if you want to. But once it's assembled, it won't break because it has hard stops. Yeah. So this one has custom supports, and where are the custom supports? Obviously, we've got this one, this one, and this one, which are the first 3 custom supports to remove. Then we've got here this one. I will probably show them better in a digital model on Fusion. How to remove them? Remember, do not remove all of them was the part of the magnetometer. It's an HMC 5883L. You can find it on Amazon and AliExpress. On AliExpress it costs way less, but still, it should be probably €7 on Amazon. Back again to this one. How to remove the custom supports. There is an order to remove them, because while you solder inside of this, you need to keep them for stability and not to break the compliant mechanism. So the first part is get one of these. probably here it's better to show. Let me see if I can show you. Okay, get the plier inside, so under here, over here. Just slowly try to get it off the piece just by pulling it down, and it removes. So as an example, this one, we've got a tiny piece that did not remove perfectly. So if we see it in the black piece, yeah, in here, here we've got a piece that remained, but still it's disconnected from the compliant mechanism, which is fine. I will remove it by hand. Yep, that's good. And then do it for all of the other two. 1 and 2. Right. Done. These other pieces, I'll show you later what they are for. Okay, the live still works great. Hardware needed: pliers, soldering iron, and these cutters. That's it. Oh, M3 way to screw. Now, I don't want to make a black one because I already have one, even if it's broken. So I will do the frost one from PCBWay. I will like it frost because when the RGB will light on, the frost will disperse all the light inside. Because I've tried with the transparent one, but it only shows the light not evenly. It just shows it in here. One thing to note, on the black one, the light will show up as a circle because it won't go through this one. But on the marble one, the light goes through, so it will show as a halo. Okay. Oh, one more thing. Remember, PETG for the compliant mechanism. That's really important. So, we can start. Oh, yeah. I also got from PCBWay this. I've always wanted one. Makes it easier to solder. That's it. But still, you can make this one without it. The first step, we're gonna start with the base. Let me see the reference one, just to be sure I won't mess it up, even though in the final video I will cut the parts. No, let's show you the electrical design. This one. Okay. Then I will start assembling, I promise. So I don't have a script, so I'm just improvising right now. Okay, so we have the Arduino Pro Micro. It can have at maximum 8 touch sensitive buttons because of the pins that it has. not the number of the pins, but the type of the pins. We have obviously ground, VCC, which is power, the red line. A3, which is a pin, will be another ground. I'll show you later why. And then 8 touch sensitive buttons. The red line, obviously VCC. The green part is the copper wire. Then we have the resistor, and then it connects to VCC. So the wires, the copper wires, will have the signal from the Arduino after the resistor. And then SCL and STA, which are the pins from the two sensors. SCL and STA. One more thing to say is that the LED has ground connected, VCC obviously, and one pin which can tell it which color to say or what pattern, which will be the pin number 14. This is the orientation of the Arduino that I'm showing. So connector up. And yeah, we can move on with the assembly. Let's start with the base. Did I show you the copper wires? Yeah, I did. Let's take the copper wires. So in the kit, I will send probably 12 strains, how do I call them? 12 lines of copper. These wires can be also, if you want to source everything by yourself, you can easily take a cable, an Ethernet cable, and strip it. Let me see if I can show an example. I don't have any. Nope. Still, Ethernet cables, strip them, and you've got wires. If the cable is Cat 6 or Cat 7, the difference will be in the thickness of the wire, from 0.6 to 0.8. They will both work. So I did the premiere for 1 o'clock and I started early by mistake. Nice. But still, I wasn't expecting people to even look at the live. So thank you. Let's start with one strip. And in here, if I show you the original mouse, let's use the black one, which is easier to see. It has these buttons right here. This, if you connect them with your finger, so if you touch them both, the Arduino knows that you touched one pin, so it's like a button. And we've got in every button, one is ground and the other is a pin on the Arduino, which means making our own buttons, one full wire will be ground. We don't need to divide it by all of the buttons on the base. And which one of two did I make it ground? The lower one. So this lower one will be ground. If we turn it, it will be the upper one. Perspective. So we can just start inserting it. And the other end on the first one. Obviously I start from the side buttons. Get pliers. Get some slack from the cables, so you can later connect it in here. And we've got the first one. You don't need to make it perfectly adhering to the base right now. I will show you how to make it later. You don't need even to glue it. Now for the second one, you can just start inserting it. And one important thing is that keep this loop small but accessible. So as you can see, I left a little loop, because once you made all the ground wires, you can just take this one and twist it, and it will tighten all the ground wires. So you don't need to be perfectly precise right now while wiring the first. Okay. Okay, the live still works great. Perfect. You don't need to tighten right now. It's fine. Just set these under and you've got the ground wires. Now, let me see the next move. Yep, we are gonna wait for that one. Okay. Let's put this one aside. And let's take the light. As you can see, the light has these tiny protrusions, if that's a word. Just cut them. Inside and outside. Okay. One moment. I'm back. LED, RGB. Now we can start soldering. Let me be sure. Yeah. Looks great. Okay. So this one is not needed right now. You can just, let's get this. I don't want to ruin my table. Get your soldering iron, that hopefully works. Solder wire as well. I use the 3D printed jig just because it works really well. This one will be needed to clean the tip. Let's just... Okay. What temperature do I use? 420. Let's prime the tip. I don't need this right now. Not even this one. And let's start priming these three pads on the hardware, on the RGB circle, which is the ground. 5 volt, and DE. D0 is not going to be used. Done. Take the resistors, attack or super glue, and let's start gluing them on the ring. And there is an order to glue them, just so you can after easily remove this part and have it cleaner, let's say. But I'm already hungry. Okay. the direction, it's not important, so you can solder it like this or like this, it's fine. And let's rotate the RGB. The perspective is if you look at the RGB light, you have the pins, the pads on the left. And you start with the first one here. Okay, make the wire go to the center of the circle. Second, third, and fourth. Okay. Then 3 again. And the last one. I'm gonna cut this. Okay, since I imagine no one is going to assemble it while watching the live stream right now, it's fine if I don't do it in the proper order. Let's put it here so it can glue, so the glue can stick. Okay, next step. Yeah, while we need to wait for the attacker, let's go to the compliant mechanism. I'll take this one. Copper wires. One thing to note is that on the compliant mechanism we have 2 normal buttons and 1 big circular one. This big circular one will be the one that can enable all 6 degrees of freedom, because you can also only move it with the magnetometer and not the gyroscope without touching this one. So if you are like in a 2D drawing and just want to go up and down, left and right, and not have to think of not tilting the knob, you can just do it without touching these parts. So you just move it. So if you try to make this mouse without buttons, that's fine, but I suggest to make at least the circular one. Obviously making it without buttons is way easier. So if you don't feel comfortable making one with all the buttons and soldering, yeah, the mouse it's way easier to assemble. Way easier. Let's start with the two circles, two big circles. We've got 4 holes right here. 1, 2, 3, 4. This is the slot for the north. So I'll start with the lower one. Give it some slack. Bend it so it stays a bit in the place. And try to wire it in the slot that I created in the 3D model. Okay, so the hole is not big enough, looks like. Take the pliers and widen it. Great. Now, to make it tight, which is not a super easy task, let's take this one. And we just get one end and a bit twist it a bit while this one is kept. Make sure it stays inside the grooves. And when you think you're done, press it. You can test it. If you can go with the finger over it and it doesn't go off the grooves, it's fine, because once the cap is inserted, it will stretch a bit all the circle or the diameter, so it will be even tighter. Again, let's look at the reference. Now to pop off the cap. Oh, I've never shown how the compliant mechanism is made inside. Look, we've got one wire for every ground, This time we can't make it. We can't make all of them connected. And one for every button. I used the jumper wires for the buttons, and as I was saying earlier, if you want to get fancy with the 0.1 millimeters wires, you can connect them to the MPU. So once the cap is inserted, it won't have much resistance. You won't feel the wires inside. But still, the first one I made with the wires, with the jumper wires inside, even for the MPU, works fine. So we'll see if I will use the 0.1 copper wires. Okay, I took off the cap just to see how I did this. Right. Let's take the circular wire off. Because we've got some more steps before that. Oh man, it's gonna be a lot of hours to make one in one live. I hope I've got the energy for it. Let's get the jumper wires. We've got 6 of them. Let's start with only 6. Heat up the soldering iron again. Okay. I'm gonna use a wire stripper. You can use a cutter as well if you want to be tribal. I'll show one with the cutter. Where do we have cutter? Got it here. One. Yeah. I'll show how to make one now with cutters, just because I had to learn it by myself and it wasn't easy. Push it with your finger, nail, just rotate it, push it again, not too much, you don't need to cut the wire inside, just the plastic. Then if you bend it, you can see the wire inside, but the plastic is cut. Keep doing it. I need to make it closer to my eyes. keep doing it until you can just take it off. Twist it so all the wires remain compact. And let's move faster. How much length do I leave on the stripped wires? See, about 3 millimeters. I wonder how many hours can I go just building the mouse without listening to anything else. The attention span of people is way lower these days, including me obviously. Okay, I've got the wire straight. Imagine assembling one mouse for 8 hours and not working. Okay, this soldering iron, it's hot. Let's start with this part. So, what are we doing right now? For the compliant mechanism, for example, for the circular part, we've got the jumper wires and the copper part connected, because I cannot make the copper wire go directly in the center because it's too rigid, so the compliant mechanism won't go back to the original position. So we need, before inserting the copper wires, we need to solder them together. It's better to solder them outside the compliant mechanism. That's why I'm making it now and not later. Now let me set up one of them and I'll show you what I mean. Let's see if I can. I guess that works. Pretty nice. Okay. I'm showing off. Just I can better show it this way. Take one wire, the jumper wires, and just solder them like they are a continuous cable. Okay. If any of you actually want some different music background, just paste the link, because I'm not listening to it. So if you want to keep the live in the background, just tell me what you want to listen. Not copyright things, please. I don't want the live stream to get shut down. If you've never soldered on pure copper wires, first make some tests, because it's not easy. Once the copper is hot enough, the solder would adhere to it pretty nicely, but it's not easy to understand how it actually works. So that's the final result. There you go. Like a continuous one. And it's pretty slim, because the idea, if you want to isolate it, you can take the heat shrinks and just pull them through. But for the compliant mechanism, you don't need to. It's fine. So we've made one long cable for the circular, for the first circle. We need to make another one long for the upper part of the circle. second one done. Now the other four. The other four have way less copper length. So you can take an entire strip and cut it in 4 equal pieces. Which is approximately, let me see the length of one. $83 millimeters. Oh, pretty precise. Still, if you make them 8 centimeters, 80 millimeters each, you will be more than fine. And each one of these 4 copper wires will be soldered to 4 jumper wires. It's not easy to arrange them and to solder, make it a continuous wire, but this helps me a lot, even though you can make it without. Just a bit more frustration. I hope someone actually makes this mouse. Oh man, I've been going for 1 hour and I'm nowhere near it. The completion. I can do this. Okay, complete mechanism. I need the video. I need something to look on. And if I need to check my live, I will check it on my computer. Here. Let me see. Okay. Yeah. Let's go on the compliance mechanism. You can set aside the soldering iron. It has a bit of stringing, but that's fine. Let's start with the big circle. The lower one is better to start off from the inside, because once you route it all the way in, you come up to the solder that you've made. And then we can bend it inside the groove. Take the jumper wire and put it inside here. No. Keep the copper wire inside the groove. Tighten by twisting. Yep, tight enough. And how is it inside? As you can see, one end has a jumper wire coming out of it, and the other end has the copper wire. So you take the cutters, cut the copper wire. Do not throw this, you might need it. And you've got this. Now for the upper wire, start from the inside, but from the other side. So once you pull it all the way in, you've got now the jumper wire that goes on the opposite side. You'll see why later. And do the same thing. Yep, great. I'm not finding my pliers. Why? I take notes. Let me see. Obviously do the same by cutting the copper wire that is too long. And the final is on top. It's this. Now make sure that these wires are not touching them. And how do you check this? Let's start with more advanced shit. Yeah, like this. How does it work? I don't really know, but there is an option where you can set it on the toner, which means the moment that these two touch, it makes a beep. So if I touch the two wires separately, if nothing happens, it's fine. If I touch the same wire, it beeps. So there is no continuity between the two wires that I made, and that's what I want. We will use this way more later. It saves hours of checking where the problem is. And what's the name of that device? I don't know. I'm not an engineer. I just fuck around and build stuff. Okay, so we've got the circular buttons. Now, if you don't want the other buttons, the build is way easier. But we won't do it easier. Let's start with the first one. The concept is the same. One from one side, one from the other, start from the inside and do the same. Always remember, keep the copper wires. You might need them. Multimeter. Thank you, Gabriel. multimeter, the right pronunciation probably. Multimeter, multimeter, yeah, like Italian spaghetti. No, sorry. Let's open this hose. I'm using this just to widen the holes. You know, 3D printing imperfections might happen. Yo, how you doing? Life is hard. What do you mean, how you doing? In what way? Right now I'm fine. I hope I can make it in one live session to build it. So that's the final result for the other button. Here. Let's make the other one. You're not seeing how I need to be. Okay, at least you can see what I'm doing, even though I'm not talking much. When I need to talk, I will. The project is going smoothly, I might say right now. Actually, 2 people on Patreon got the 3D files, the digital files, the modifiable ones also, with the step. I wasn't expecting that, and I did not put inside the file the bill of materials and the electrical design. I will send them after the video. I wasn't expecting people to actually buy the digital files. which is great, actually. Pretty cool. And how am I doing also? Right now fine. Could be better. Could be way worse. Actually, what about you guys? Did you just find the live video and connect it by chance, or were you already looking at my first videos, like the first mouse that I made? And what do you think about making live session where I build stuff? Could be interesting. I can't wait to show you my patented 3D scanner and talk about it, improve it also. That might be a really nice video. Great. So the compliant mechanism is done. We've got the two buttons and the big circle one. Now, to ensure they will never move out of this position because they are a bit tight, but with time, obviously, you never know. Glue them. One thing before gluing them, wait, don't do it right now. Wait till I glue mine. Is that on the circular part, since this tiny piece is the slot for the north cap, do not put super glue that covers this part, but put it under. Only on one side is fine. Now let's check if everything is fine. Yep, looks great to me. We've got 6 wires coming out of the compliant mechanism, and these all wired up. Let's set it aside. Let's go back to the ring. So what have we done? Only the ground wires. Okay. let's start working on the ring. So we need to connect all the resistors to ground, and to do so, since we glued them on here, you can just lift the parts, the wires that are going inside of the ring, like this. Take one copper wire, 0.6 millimeters. I'm gonna take the one that I cut from the first ring, and we will solder them like this, like closing the circle, so it's tidy and pretty nice. Leave some slack for the first copper wire to also be long enough to go on the ground pin on the LED. And let's start soldering. Wait till it goes hot. Okay. Okay. This is the first one I've made. So right now I can already bend it to ground. Let me see how I did it here. Perfect. So now it's soldered on the ground pin as well. We can cut the excess. And start soldering in the circle. Also, once you solder the ground part, you can cut the vertical wire that you made. Obviously check if the connection is made. This one needs a bit more solder. I just need two more. Okay. This is the final result of the ground wire. It looks good. Do I need it to make it longer? No, I don't. So I can also cut this other end. Next step. Oh, I made a mistake. Let me see if I can throw it also. Okay, I said it right in the beginning and soldered it wrong. The resistors need to be connected to 5 volts, not ground. So, what are we gonna do? Desolder the part on the LED. Yep. And reach. For the 5-volt pin. Easy fix. How am I going to show this properly when taking the parts from the live? I don't know. I'll find a way. So it's connected to the 5-volt pin and it's fixed. Now, next steps. Take a strip of the wires that you cut earlier from the second ring, which is long enough for this scope. Solder it to the ground pin on the LED. And wire this cable on the ring. And glue it. and wait. I need to keep it tension with my fingers. Wait, it was faster than expected. Obviously the ground wire and the 5-volt wire, they are not touching. Yo, hi Asa. Papa? Oh, why Papa? Great. This one is done. Yep. Bold big boy with the mouse in the house. Big boy as well. Always trying to remember. What is the always trying to remember? Keep the body in check and your mind will be in check. Okay, next step. I like the energy you're bringing, Kaza. Really cool. Yes, 40 times a day. You need to be in check. Never skip muscle day. How many wires do they have on the bottom? Where am I from? I'm from Romania, but I was born in Romania, but I lived most of my life in Italy. So I actually speak better Italian than Romanian. Pizza pasta mandolino, or pasta di pesto. You can also hear it in my English. It's like a bit of spaghetti English, which is fine. Okay. Now we are going to wire. See ya. Let's wire the 1, 2, 3, 4, 5 wires on the bottom. So we need to cut an entire strip in 5 parts. Approximately 8 centimeters each, even 6 centimeters, it's fine. Yep, let's measure it. Yeah, even if it's 6 centimeters, it's long enough. Is this actually 6 centimeters? Damn. Okay. I wish you will donate $100, but I don't believe you, which is fine. It's fine. You don't have to. 28. No, I don't have any kids. I don't plan on having kids right now, obviously. At 33, 34, I would like to have at least one kid. Could be nice. He's 1 year old and you just give him the soldering iron and say, solder. Learn. You need the skills. Cut the wood. I get it. I get it. That's fine. Okay, where were we? Here. We get a circular ring. Where are you from, Asa? Thank you. When I'm rich, I will retire you. Of course, do it. I will keep the lives coming. And I will wait for you to be rich. What do you do? Do you work? How old are you? Okay, to solder these wires, you don't need... but I will. Fuck it, I have it, why not? Let's use more hands. Australia, yo. Could be nice in the future. You should become a woodwork teacher or system tech at a high school. I think I might like it. But still, to do so, I probably would need way more, how do I say it? I would need more on paper, like studied particular things. I just learned it all by myself, so who really believes me that I can do all of these things? Objectively, it's hard to believe it just from the standpoint that I did it by myself. I'm looking for a job actually, because my company is going to close, unluckily. Do you have another job apart from YouTube? So, I had one job. I had my own company. And I patented a 3D scanner. The company still is It's not closed yet. It is going to close because on trending, hell yeah, that's the start. I actually don't know how many people are on the live. Let me see. 2. Imagine. Seven. Shit. That's good. Good news. Move to Australia. That's not a bad idea, actually. That's not a bad idea. Obviously it takes money to move to Australia. But who knows? In the near future. Who knows? I might consider it, actually. I like colder places. Italy is too hot for me. Nope, not near enough. Much better. Oh, well, as I was saying, my own company is going to close. So tomorrow I have an interview for a job as a mechanical engineer. Even though I haven't studied engineering, I found myself without even realizing it. I was doing all the things that engineers do. Raining and 15 degrees right now. It's lovely, actually. $35 degrees if you're lucky. 44, 45 degrees on bad days. And it's a lot. This one. Okay, so I'm soldering the extensions of every resistor. I will need to do it for only 5 of them. And guess what? I did it for one of the 3 that I should have not. That's fine. Let's desolder it. I wonder how much a mechanical engineer can gain monetarily, monthly. Then you can show all the builds your weapons. Well, do you know the concept of the male body inflation, where a muscular body right now is considered below average, where where 20 years ago a body like mine would have been way over the standard. Right now I probably can be labeled as fat or not fit, even though I train with the gym rings. So I think I'm pretty strong for my weight. What are the buttons that I need to do? 1, 2, 3, 4, 5. Okay, so before starting, the resistors that will have an extension are the first, 3rd, 4th, 5th, 6th. That's it. The other 3 will be connected to the wires coming from the compliance mechanism. because of all of the supplements cheating. Yeah, it is cheating, but the average people do not know what a body can be achieved without all these supplements. So if more guys show like the fake natties, if more guys become fake natties, everyone will believe that's naturally available, achievable. Which means my body is average. Natural for the win, yeah. Yep. Train naturally, be a psychopath while training, and you will get the body you want. First one. There you go. Hello? Yo, Swazira. Another guy on the live. So since probably there are... Thank you. I started watching YouTube videos at probably 10 because I liked playing Minecraft, and there were no Italian YouTubers that were good at Minecraft. So I started since I was actually really tiny, and all my knowledge is from YouTube, and everything that I know to do, even building this mouse, was entirely from knowledge from YouTube. Oh, for the people that connected without actually knowing what am I doing, I'm building a space mouse that I made it myself. This one. This is a transparent one. It's way cheaper, and it works like an actual space mouse. The original mouse that I copied costs 400 euros, or 200 if you want only the knob. Mine, if you get the parts from AliExpress, it's $15. It took me 2 years to make it, actually. Favorite Minecraft YouTuber? I don't watch Minecraft YouTubers anymore. But when I was 10, my favorite one was what's the name? I don't even think I remember the names. Nope. I don't remember the names. I liked building in Minecraft. Then from Minecraft I fast moved from to League of Legends. I've played for 8 years League of Legends. Man, I loved it. Man, I've played a lot. I actually reached the Diamond, where Diamond was the highest tier. So many memories. Oh man. So, the moment I solder one extension, I can just cut the other part, so it remains only the copper wire. So remember, it was the first, the third, fourth, fifth, sixth. The others three, leave them there for the moment. To be successful in life. So any tips for me to be successful in life coming from a guy like you with 28 years of experience? The years where I actually had a good experience, not to be successful but to know what I want to do in my life, were in the 3 years where I started my own company. Not because I was making money in my company, because I was not. I was just reinvesting everything. It was having the ability to explore creating things, or explore probably subjects that I was interested, but with a lighter weight. What do I mean by this? Let's say having not having the burden of having to do something with my life, but just waking up, learning things that I liked, or probably trying different things, and realizing that I like to build stuff. I started with 3D printers, I made my own 3D printer, I 3D printed a CNC machine, and all of the things. Do you have a version 1 of this mouse? Yep, I do. Do I have it here? Yeah. Wait, first I need to answer Azza. Any tips? The tip that I can actually give you is first answer me this question. Is there something that you see yourself doing when you are 90 years old? Find the answer to that question. If you are only 16 right now, don't think about the money. Because there is this YouTuber that said once, at the start of your life you've got the thing that you mostly have is time, and the less of it is money. And then the more times goes on, the more it shifts. Then you have less time and more money. Thank you. So just answer the question I did you earlier. Find something that you see yourself doing when you are 90 years old. And it should be something that you are able to do by yourself. Because having something that requires another person is way harder, in my opinion. So, do you have version 1 of this mouse? Yep, I do. That's the version 1. So it's not only a mouse, you can see the copper wires as well. It's like a staple right now, even under here. This is the mouse primarily. It's just a PlayStation 2 Joy-Con. So it has all the movement that normal Joy-Con has, and it clicks on the right and left movements for another degree of movement. and the shape. Let's move it aside for a second. The shape of this mouse. So here we've got the swappable key switches that I've removed. Here we've got the wrist rest that right now I'm using for other purposes, other projects. So I've removed it from the original mouse. But this one is... No, what? My phone died. Let's hope not. 1 second. Yep, my phone died. Let me see if it's a battery problem. What's so special about this mouse? 1 second and I will tell you. I need to revive my phone. Okay, so it's a battery problem. So let's try this. 1 second. Fuck, this is a really big problem. So we need to fix it in a different way. We will connect the phone to fast charge. Damn. I'm going to head off bed now since it's 10:15 p.m. here in Australia. Yep, do it. Sleep well, obviously. It's really important to sleep well. Best of luck of tomorrow in your job interview. Thank you. I don't know why my phone is probably it's just overheated. We will see. Thank you, Asa. Come back to my videos if you can. Okay, so we need something in the meantime that my phone looks like it's not working. So we're gonna do this. Sorry, 1 moment. Nope, it's too tiny. Man, right now that I had actual viewers on my channel, my phone decided to just die. Well, that's on me for using the phone as a webcam. So, well, you'll need to wait for a way to fix it. So in the meantime, I do this. What else can I do? What's so special about this mouse? If you mean the second mouse, it's that it has full 6 degrees of freedom, so I can move it up and down, left and right, and every type of movement that I want, and it comes back like a spring motion. I will show how it translates on the computer. I need to actually fix this problem somehow. So I'll try and do this. I'll take off the cable that allows for quick charge. Okay, so now my phone is starting up. These are all mouse mod blanks. Yeah. Is it for people with disabilities? What's the use case for it? It could be used for people with disabilities. I just did it because I wanted a mouse with that shape. Nothing more, nothing less. But yes, it can be used easier for people with disabilities, especially the first one, because the distance for the fingers it's made precisely for my hand. And in the original file, if you take the measurements of your fingers and say your middle finger is longer by 4 centimeters, the model automatically shifts the part further away. So it's like a parametric model. Okay, so my phone is up. Now, let's connect it again. I cannot use the cables anymore because it's not going to charge my phone. So I will need to use the device IP. I hope it won't lag. We will see. We'll see. In the meantime, I can still answer things. Let's go to the phone. Deactivate. Use Wi-Fi IP. Wi-Fi IP. One 192.168. 1.11.
Perfect.
Yep. Let's see. Looks like it works. Let's wrong one. Better. Ooh. Damn, the refresh rate is bad. Okay. I would love to try the finished version of it. It looks cool. Yeah, it does. And it works really nicely. I need to fix this. So it looks like that device wasn't charging it enough, but maybe directly from my computer I can do it. I'll try again. So let's do this fast. Disconnect it. Let's go over and connect it directly to my computer. Let's remove everything that can impede my phone. Let's go on power saving mode as well. It's going down, I don't know why. Let's see. It's still on, even if it's at 1%. Since I have disability myself, that's why I asked it if it's for disabled people. It does work nicely, especially if you have finger problems. Or problems, let's say disabilities with fingers. It's charging. Okay, so I can put this here. Let's try and connect it. Man, if only I had an actual camera. I'm not seeing the phone. But it's charging. So let's just... There you go. Debugging started. So right now it should work. Please tell me to... Yeah, I'm not seeing anything. Don't know why. Did it. I did it. Hell yeah. Hell yeah, we're back. Make this one smaller. Nice. It works. Great. So, Daxter, I hope you are still here. If you want this mouse, these parts, so I'm actually selling only the digital models for this mouse, because let's say the way that I want to handle all the digital models is that if I come up with a newer version of mouse like this one, the older mouse becomes free. So if you actually want these files, or if you want me to modify them for you and just send to you what you need, text me on YouTube or here and we'll keep in contact. I'll put it aside. There you go. Okay, we can cerebral palsy. Maybe it's worth getting it for people who have disabilities that affect fingers. Mine affect it, but I can easily use a leg mouse. Okay, I get it. I think it is worth getting it for people who have disabilities, but still, the algorithm on YouTube it's not going to push my things. I'm not a full-time YouTuber. I'm not great at making videos. I think I'm decent at creating things. So I don't really know for a solution. How much is it? The first version or the second one? And I imagine you're asking how much is it to build one. Where was I? Here. Okay. At least I fixed the problem. I agree, Eugene. This is a mouse for moving in 3D space, but as I was saying earlier, this type of mouse, you can, since the firmware is open source, you can make it move everything that you need. So if you just want to move a mouse and go right, left, up and down, you can just habilitate the magnetometer, and once it's on the table, you just move it up you just move it up and down, left and right, and it just moves the mouse. So that's the cool thing of having it open source. You can make it do everything that you need. Same with the joystick for the first version. You just tilt it up, goes up, tilt down, goes down. So you don't have this type of mouse and have to do a precise movement, but you just pull it up and goes up. So it is modifiable for what you need. Don't get stuck on it's created for this purpose, because the goal of what I created is that do whatever you want with it. If you want it only to use 2 degrees and move only a mouse, do it. That's more than fine. Now, let's go back to soldering. But I will never finish this mouse. I really hope I can do it in, what time is it? 2:30. Okay, I've got some more hours to do it. Let me see actually how many people are on the line. Still 7? Okay, nice. Thank you. Let's move on. Is there something that I haven't responded to? Your beard is cool. Thank you. I want to make a beard braid in the center, a big one, but I need to make it grow even more. And it's weird having a big beard. I'm not used to it. We are back. Yep. Luckily I fixed the phone. Is the audio, the music still going? It's almost finished. I will going to reset it. It's really cool what you do. Keep it up and don't give up. Thank you. It's not easy. I don't think this is something that can make me live with it. So economically it's not viable to create, even though I would love it. I will keep doing it. I have a lot of things that I created. I just need to make videos about it. Why did I solder this one? Okay, it's fine. Oh, you haven't told me about how much is it. Do you mean the first version or the second one? But still, why do I need to wait for an answer? I'll tell you both. The first one, to create it in raw materials, the joystick was about on Amazon $3, and the 3D printed parts, probably you need to buy 1 kilo and then print with that, but it's probably 7 grams, so let's say 20 cents. The connection to the Arduino can be only with wires, you don't have to do it in the shape that I've done, and it could be, if you only buy this part, these wires from Amazon, probably €3 again, and it's done, only for the movement part, which is, I think, the most viable one, the most useful one. For this mouse, the parts, if you source them from AliExpress without having anything for it, it costs $50. If you already have all the parts, and let's say you only need to buy the magnetometer, the gyroscope, and then the Arduino, it costs on AliExpress $15, and on Amazon a bit more, be 3 times more. And if you want, yeah, the digital, I'm selling the digital models. I don't know how I feel about it, even though I should feel good. I should feel positively about selling the digital models. In my perfect world, I should not need to sell the digital files. Let's keep soldering. I could play games on it if it's reprogrammable, and I'm sure it is, since it's open source. Yep, it wouldn't be comfortable, but it's still doable. To reprogram it, probably. Yeah, it's not easy. It's made in C++, the second version of the mouse. But I could help you. Actually, if you want to just ask me some questions on how you want to make the mouse, I will gladly help you to make the version that you need. Even for the shape, who knows? Maybe not a circular knob, but a different shape, easier to grab onto. Could work. Okay, we're back. And the last one. Man, my phone dying on me stressed me out. I need to chill down a bit. Wait. Now. We've done the 5 wires. Let's take the base that we've done. So, having the USB-C pointing at you, take the right copper wire that we've left longer and cut it. You don't need it to be longer, you need the other side to be longer. Now, obviously you won't remember, but I do. We've done these tiny circles on every button, which is the ground in this case, to tighten it. So we just take it and tighten it. So in here it's flush with the part. Once it's tight, move it up like this, and it won't go anywhere. And let's do it on all of them. Wait. Don't over tighten it because you can break the copper wire. It doesn't need to be perfect. Once it's tight enough, it's fine. Yep. Next one. And for the last one, it doesn't have a way to tighten it. You just press it, and this one keep it longer. Because right now we will take our LED ring, move this up, the extensions that we've made, and the ones that we haven't touched. And now the base with the USB-C pointing at you. Insert the LED ring with the copper with the strips, with the pins of the LED on the left. It has a perfect slot because you can even make it higher or lower, but still make it on the left. And glue it. So it doesn't move. Don't need to overdo with the glue. Just 2 drops and wait. And wait. Now, while this one it's in there, let's see the next steps. Okay. Okay, now on the hard part. Let's see if this one, no. Let's add more glue, even though I said don't overdo it. I think by moving it, I removed the attachments point. Okay. Leave it there. Let's go on the first electronic part, the gyroscope. You have 2 options to wire the gyroscope to the Arduino. The hard way, with the 0.1mm copper wires, and the easy way, jumper wires. Which one are we gonna do? Oh, my phone died again. Let me see. Yeah. My phone died again. Yep, my phone died again. So, bad news obviously. Let's quick charge it. Okay, so let's do this. Since I need my phone to actually have the table streamed properly. Let's do this. I'm changing the outputs. Nice. Let's open Fusion 360. And let's eat and show people how the mouse works. That's the best thing that I could come up with no time. I need to eat. Yeah, 3 watching. I get it. That's fine. If my phone decided to die, what can I do, right? It was nice having people on the live. So let's show the mouse. Should be it. Yeah. My phone just dies. Okay, so let's connect the mouse and show how it works. So when I make the cut from this live for an actual tutorial without 10 hours of me just yapping, I can show how it works. Let's take a cable. So, how do I actually show it? Let me see if the phone is charging. So what's the plan right now? Let me see OBS. There you go. And once you touch the ring, it becomes green, which means all the 6 degrees of freedom are available, and you can move it as a space mouse. Move up, move down, left to right, rotate it as you wish. If you don't touch the ring, you just have the magnet. So even if I bend it, the gyroscope does not work. Only these parts work. This is made for a 2D design, and this is for all of them. Okay. Let me see how my phone is going. Yeah, 5%. I can't do more than this. So I'll just pop out the chat. Cannot do this. What's the meaning of popping it out if I cannot take it outside? Right. I need to eat. So I'm gonna eat actually. The live looks to be way lower. Way back in time. I'm sorry to everyone. I need to wait and charge my phone. Oh, I'll just stay here for a bit. How do I fix the problem with my phone down? I need to set up the webcam. But still, I want myself to be seen. This could be an idea. Let's see. It's not there. Let's see here. Now, let's see. If I do this, okay, so the phone is charging. Is it connected to my PC? I don't think so. Let's see. Yo, bye. Sorry for having the stream destroyed by itself. Good night, Gabriel. doesn't seem to be connected. Yeah. Thanks. Come back for my videos if you ever feel like it. How about this solution?
Perfect.
Let's see. No. Come on. Let's do this. You don't have to see this. Oh no, you do. Okay. Let's see. Maybe this time. This time. Good. Let's see the phone. I need to dim. Okay. Maybe this might work. check. Okay. We'll see. We'll see if it works. Oh, the live really is behind on my end. Okay. Well, I'm back. I hope my phone does not die on me again. But if it does, well, let's try. What can I say? Where were we? Here. Nope, not here. But gyroscope. So, the hard way or the easy way? The hard way. Because if you already did all the things that I've done here, you can do the easy way. But it doesn't mean you can do the hard way. And the tutorial needs to be complete. So, let's go with the hard way. First, I'll remove the scotch. Right. Fucking. Yeah. Oh, I'm so sad. I had so many people watching me. And then technical difficulties. That's fine. I say that's fine, but I don't feel like it. So, one thing to note. These wires they have a layer outside the copper, which means if it touches another wire of 0.1 millimeters, it's not going to connect with it. And that's important, because inside of the mouse, if you want to do the hard part, which means soldering these 4 tiny wires, they will touch them, because once you insert it, they obviously will. So they have to be shielded somehow. And don't worry, the moment that you solder it, it reaches the temperature where the external thing that it's there just evaporates, so it becomes conductive. What's the length that I will do in this? Approximately, which means how much is this? It doesn't have to be too long, because if it is too long, I have the impression that the signal won't be reliable for the gyroscope. So 8 centimeters max. Maximum 8 centimeters. I'm gonna do 6. Let's go. We need to cut 4 of them. Let me see the phone, it still is going. Yeah. Let's start again. We've said 6 centimeters. Around, obviously. Nope, I'm gonna do 8. Another important thing, they don't have to be exactly to the millimeter the same length. Because you might think, yo, SCL and SDA, which are the 2 pins that get the information to the Arduino, need to be synchronized. Yeah, they need. But for the scope of just having a mouse, you don't need that precision. So, around 8, it's fine. Remember, 4 of them. Wait. There you go. Great. So, how do the wires need to be soldered on this? we will solder on the first 4 pins. So let's start with power pin. You can just bend it, it stays in. Heat up the soldering station, obviously. I really hope the phone works. Okay. Is it out of focus? Now it's in focus. Yep, now it's in focus. There you go. Okay, so how's the first one? Next. Ground. Yep. Now the other two. Nice. And the last one. Great. Now I've soldered all of the 4 wires. Cut the under part so they don't touch each other. You don't need to cut the solder as well. Great. Now, take a piece of paper, that's important, and sign this. The MPU 6050 this, and type how the pins are arranged. You need to remember this, obviously, to do it, because once it's set in, it won't be easy to find, unless you want to search it online, but yeah. Same with the magnetometer. Here, to remember how this one is pinned, make 5 points and just type 4 of them, because since you are going to use only 4 and you have the magnetometer glued like this, you can easily tell from where it starts, since you have one that you are not going to use. And yeah, remember this part, or just make a screenshot of this. Okay, next step. The ring is glued. Let's insert the wires. So, we've got these 5 extensions that we've made. Oh, important. Take the heat shrink, because if you want to insert LED balls inside, they are conductive. Not much, but they are conductive. And for pins like ground and VCC, they are pretty near to each other, and one LED ball in here will connect them, and the mouse shuts down. Same with here. So, obviously, for the buttons as well, you've got all the grounds that are really near the pins. So we just cut off a piece. How long should it be? It should be longer. How do I fucking explain this? Let's make a standard. Okay. Cut them all at 25 millimeters. precisely this time. Where is the scissor? Why can I not find the scissor? One at a reference 25. Great, then all of them follow. How many of them? Let's see. For now, 5. Okay. Yeah, insert the heat shrinks to all of 5 extensions. Oh, sorry. Okay, and shrink them before inserting the copper wires. I'm gonna use a heat gun. You can use a lighter as well, but be careful. Okay, this is resin, which means it became softer, so let's just wait a bit. Yeah, let's let it cool a bit. Next step, while this cools, we come back to this magnetometer, gyroscope. Let's take the cup. Let's take the magnet. Whichever way you want. We are going to modify it by your preference in the code. So just glue. Not too much, you don't need much. And insert it. Perfectly covering the magnet. Great. Well, nothing much to say, actually. No, it's in. Another thing to remember is the orientation of the gyroscope that needs to be glued to the cap. So we've got the north, which is this tiny red piece, and on the gyroscope we've got the X and Y. And the thing to remember is that, let me see here, just to be sure, the direction of Y needs to go south. So, if the north is this red one, the north will point to you, and the Y will go to the opposite direction. And this is how it needs to be glued. And we will do it now. You need to be precise on how it's centered. The more precise you are, the better it is. To how perpendicular this is to the north. And this one is done. Now, let's come back to the base. It's hard enough, so we can move with it. Right. So, the first button, this one, goes inside the first strip. And as you can see, let's make it clear. There you go. The heat shrinks that we've done are longer than needed, but that's by design, because once you on the underside pull the copper wire, you have the heat shrink covering all of the wire, which means the ground wire won't be touching this here if you add the lead balls inside, or a conductive material. So remember, not this one. Let's insert it in the other as well. So it just goes in and pull on it. Not too much, or you will break it. Flatten it with your fingers. And there you go. The first one is done. Now to the other. Let's fix the beard. Okay. Third one. Great. 2 more. Okay, last one. Be delicate with the wires. They bend easily. You need to have patience to actually make one. Done. So the wires are in. Whew. Next. Let's move with the knob. No, let's wait. Let's wait. No. It's better to do it right now. So, let's take the knob. Insert it. Insert all the cables at the center. Let's take 3 of the M3 screws and the north tab needs to be in the same direction of the USB-C port. So, like this. Great. So, one step closer to the full mouse. We have all the buttons inserted. Now we've got these 6 wires, which will need to be cut and soldered pretty tight. Let's take a second of break. Okay, the pause is done. 10 seconds. So, again, let's take our paper. And the rule we are going to apply is that the bottom buttons, the bottom wires, which means this one, will be ground. So the colors yellow, orange and green what was this? The sign of ground, just fancy. It's ground. And the circle it's blue. And then with north pointing not to me but in front of me. We've got left button with the color brown and right button red. This is important. So, let's start with the ground pins. Yellow, orange and green. Yellow, orange and green. These 3 wires need to be connected to ground. So, Let's connect them to ground. Let's cut around let's say 5 centimeters the length of these wires. Let's strip them. Okay, so what did I do here? I've got the 3 cables. I pinched the copper cable, lifted it up a bit, inserted the 3 cables, pushed it down a bit again, so it's easy to solder all of them together. Let's wait for the soldering station to heat up. Let's go. Let me see if I can show you. Right. So, why did we cut the cables on that length? Because you need a bit of slack for these parts, so the movement can be done easily. We haven't removed the custom supports yet. Wait, still. But now we have enough slack for the cables to just adjust it and be sure that we can move it without any problem. Now the other three of them. We had the circle, which is blue, and again, now let's make the ground of the other wires connect to the ground pin. So the extension, ground, just put it, let's say in here. Yeah, like this is fine. I just made it go under the main ground pin. Solder them together, cut the excess. It's done. Keep them, remember. Okay, now the 3 more pins. The circle is blue, and the blue button needs to be soldered. Let's see. This is the circle. So USB-C pointing at you, the second on the right, the short one in this case, will be the circle button. You can solder the circle button on these two as well, but you need to do more work on the firmware. Still, I will show you how to do it in the software firmware. Now, the blue was the circle, yeah. How do we do this? Let's wire it under the copper ring, so it's tidy. And with the strip wire, we cut a section, but we do not destroy the cable. What does this mean? Do this. You can do it by hand, obviously, as usual. It's just harder. And once you've got that, you just circle it around. Weird. Remember to get some slack off the cable as well for the movement, obviously. Cut 3 heat shrinks. What length? 2 centimeters each. So for every cable that you insert a heat shrink as well. So now the other ones. The left button will be connected to, let's see, it's the same color. So the left with USB-C pointing at you is to the left one, which means the first counting from the left. Remember to make it under the copper circle to make it more organized. Leave some space. And do the same thing. Or nothing. The moment that you create this tiny part, twist it. So this becomes stronger. Let's solder it. And the last one. No, I've destroyed the cable. Okay. Let's fix the cable. Nothing more to do. So, how do we fix it? So, what have I done? I've cut the cable. So, let's strip it. And let's solder it on the first part. Okay, so the first one is connected. It's a bit too big, so it's too wide. This part is too wide to insert the heat shrinks, so I'm gonna cut it. See? Nice. And let's solder the next one as well. Now we need more hands. Yo, RJ Repoman, I never catch your streams. How much longer are you going to be streaming? For a lot of wires, wires, for a lot of hours, and that's my first stream. A lot of wires, man. All this soldering is getting to me. I think at least 4 hours. Hopefully less. Done. I fixed even the error. So now let's shrink the inserts. 1, 2, 3. Done. Let it cool down. Yep. Next step. What else do we need? Keycard. Do you know how to use keycard? You mean the CAD part or the PCB design part? But still, yeah, the CAD part I do. But all my projects are done in Fusion 360. But the file extension is compatible with KiCad as well. The step. you would be able to produce them much quicker with manufactured PCBs. Yep, I would. I did not have the time to do it. I did not have the will to do it because it took a long time to make the mouse, and I wanted to make it available for people before someone else managed to make it like this. So full 6 degrees of freedom working perfectly. And yeah, in the future I would love to make a custom PCB, but this is not my job, so it's not going to be something that I will do right now. If it was my job, probably in 2 weeks of full day work will be more than enough to make custom PCBs, which will allow me to even sell the mouse, but still I don't think I'm going to make it my job. I don't know if sadly or not sadly, but it might be a future project. Look, while I was designing this mouse, I even considered instead of using magnetometer and a gyroscope, light sensors, which will remove all the downsides of having these two sensors. Light intensity sensors, and here it's better, light intensity sensors and one light at the center. I think this is patent infringement for the original Space Mouse because it uses light. It has like 47 patents on it, so who knows if this part is patented. I would like to make a version of it with light as well, but still, it takes time and energy to make one. And the compliant mechanism, I think it's the most important thing of this mouse. It was not intended to industrial manufacturing and easier to do, because I just wanted to make a mouse, not to profit from it. I'm not even sure if I'm going to sell them on Etsy. No one ordered one yet, but I'm not sure. Even if someone orders it, I'm not sure if I will say, yeah, of course I'll send one to you. That's the story. I had experience with designing PCBs as well. I did it for my keyboard, which in the video I've made I barely shown it because I'm bad at making videos and I got lost in the sauce of being funny. So I do know how to make a PCB. Probably I won't do it right now. For sure I'm not going to do it right now. It could be way easier to make, obviously. I agree. Patents get in the way of all kinds of things, from being developed, holding us back as a humankind, I think. I agree. Funny thing is, I do have a patent myself for a 3D scanner that uses photogrammetry. It wasn't my idea to do it. We even tried to make a company out of it. We failed. Which means I will probably make a video about it and make the patent fall down. And the problem with the patents is that, imagine I'm a company with Three people. We have no money. The Apple comes to us and says, I'm gonna use your device, sue me. They can stay in court and have the money to prolong it so much that we will finish all the money we have for all the processes. They will not win, they will not lose, and they can still continue using our stuff, infringing the patent, because we don't have the money to resist all the time inside the court. So the patents are bad in any way. They work only if you want to sell your company. It's like a valuable thing for the company. If you are a big company. If you are a small company like it was mine, no one cares. We just wasted our money. It costed 3,000 euros and 1 year of work to getting it accepted. So let's say we worked for it 3 months, and we delayed our device or the selling of our device because we were scared that they are going to copy us. They can copy everything. They just smear a pink coat on it, and it's outside of the patent. So it's useless. But they could just come at me and say, yo, it's patented, give us the money. And I'm gonna say, what money? I'm poor. And that's it. And I go to jail, probably. If they really wanted to. Unless I make it open source and not gain anything from it. Yeah, that was a big rant on the patents. I've got a pretty big grudge about patents, having had the experience with it firsthand in the company. It's cool to say I have a patent, but in reality, it's nothing. It's just something to brag about, if you are just a guy. Probably even if you are a company, unless you patent like an iPhone. But it's usually made from 70 people altogether. Now, next step. Let's wear the buttons. The extensions of the buttons. No, let's wait. Let's do the gyroscope. No, my phone died again. Okay, let me see. Yeah, I think my phone died again. Let's get the cable. Okay, so this time it stayed a bit longer. But it is not something I can keep doing for long, because my phone camera does not charge fast enough. How do we fix this problem? But at least I'm close to finishing it. So probably 10 minutes of charge will get me 40 minutes of camera. In the meantime, if you have any question. Like an S7 watching. When people are watching, my camera dies. Great. I can use this one. I can use this one. Could I? Let's see. Huh? Ooh. Okay, so in the meantime that my phone charges, that's a good solution. Let's do this. Get it further away. That's a great solution. Nice. Let's see if I can make it further away. Man, great. That's great. That's probably even better than having two cameras. It autofocuses a lot. Maybe that's a bit of an annoying, but it's great. Okay, so we are going to move on like this until my phone charges. Yeah. Now, next step, the extensions for the wires, for the 5 buttons. So we take 5 strips of the jumper wires. Separate them, then we strip the ends and we solder them to the 5 copper wires we've put in the base. Yeah, my phone is at 0%. But this is great. This is great. I don't think I even need my phone anymore. Just need to focus a bit more on the shot. And yeah, let's do that. Okay. So one cable is here. That's the solder station again. Okay, one is done. Okay, let me show you how I did the cable. This one. The extension, so the wire goes first from 5 volts to the resistor inside here, and where it comes out you solder it to the jumper wire and insert a heat shrink. About 2 centimeters for each, it's fine. How many? 5. And shove it the more you can, the better it is. So the ground wire will not touch this upper wire if you intend to insert weights inside that are conductive. And let's do the other 4. You can't see anything. Better. Yep. Okay. Next wires. Wait. Last two. Yep. Last one. Okay, so the 5 cables are soldered. Let's first take another cable and connect it to the pad D1 on the LED circle. Great. This one is done too. Let's heat shrink the 5 we've inserted for the new wires. Leave it to cool down. Yeah, it's softer right now. Yeah, let's do this. I'll take 2 minutes of pause. and go to the bottom. I'm back. So where are we now? We are missing soldering the gyroscope to the base. Soldering the magnetometer. And then everything to the Arduino. But the hard part is done. Let's continue. It was such a great idea to assemble one in one live only. Yeah, best idea ever. Okay, next. Let's solder the gyroscope. Now, the gyroscope, since we chose to do it the hard way, we've got these 4 tiny wires, 0.1 millimeters, and since they are coated externally, we have no way to know which one connects to where if we can see this part. So, what's the game plan here? I work with a group of people called the 3 pieces controllers. Yeah. 3 pieces controllers. I'm interested. You make different kind of controllers, I imagine. Okay, even wiring these 4 parts is not easy. We make the Polybar Guitar Hero controller. Never heard of it. Probably it's something that I have already seen. Let me see. Let me search for it. Polybar Guitar. So yeah. Good night. Okay, so we managed to make 3 go through, and the 4th one. There you go, all 4 of them. Great stream, thank you. Right. No. This won't be easy. Not even to show. But if you chose the hard way, I really hope you are good at soldering and have patience and steady hands and patience and patience. So what's the game plan? We separate them so I can see the 4 wires from on the gyroscope and from the center. If I take one of the wires and pull on it, I can see which one moves, so I know what wires I'm dealing with. I'm not seeing it. One, two, three, four. Why did I even choose the art? Oh. So, not this one. This is ground. So move aside all of them. And I found the ground pin. Now let's solder the ground pin. I need a better pliers. Much better. Okay, so now that we are working with these really hard to maneuver cables, this fucking better pliers, much better. Oh yes. Get under you. Oh, finally. Now I can solder it. Okay. Oh, that was hard. Let's wait for the soldering station. Let's see in the meantime how many people are on the live. 4. Nice. Thank you for staying in the live. Let's reset it. Let's move onwards. Now, I've soldered the first one. Every cable you solder, if you chose the hard part, check every 0.1 cable if it's white. I've shown earlier how it works, and for those who still do not know, it's called damn, the guy actually told me what it's called. Multimeter. It's called multimeter. Set it on the musical note. When it touches, it beeps, which means if you touch a cable that is connected to itself, it tells you that it's a continuous. It tells the continuity. So let's connect ground outside of the solder to the ground. It's not working. Not working. Not working. What the fuck? Is it the wrong cable? Not even the wrong cable. What the fuck? Okay. Let's see what happened. Okay, so the ground pin, this is the cable, this is the right cable. Probably I did not hit the cable enough, so the coating did not wear off. Let's see. Let's see. Still nothing. Then what? Probably at the end of the ground, then on the gyroscope. It's not working. Let's see. Okay, let's try again. What? What is this? Let's try again. Oh, okay. Nice. It wasn't soldered. That's a great sign, because it means I know the problem. Now it should work. music to my ears. One is done. Next. One moment. Let me check if actually some. No news. Next. This is the power. Let's put them aside and connect. Great. Next one. Let's check. Remember, everyone you solder on the point 1, check. Oh, yes. Yes. Now, SCL and SDA. They will be. We need to solder the extensions on it. So we take 2 cables. Splice them. How do we handle this? First, find out which one is the SCL. Great. SCL, SDA. So I can. Great. Now, take 1 cable, Okay, they are connected. You can see it perfectly. But still, as I told you, if you chose the hard way, you know what you're getting into. Get the heat shrinks again. Cut 2 of them for the SCL and STA extensions that we've done. Oh, I've realized we finished to make the wires and we have left 1, 2, 3, 4, 5, 6. So I will get you double the wires you need. Pretty generous of me. If I actually decide to sell them. Since no one bought one yet, I'm not sure if I will ever sell one. Not even if someone tries to buy one. I can still say no, I won't sell it to you. Okay, one extension is done. Let's say now let's remember yellow MPU SCL and orange MPU, it's SDA. Check. No, first solder the last one. Yeah, let's solder the last one. Yeah, I'm not happy. Right. No. Okay, now let's check. Right? So I've said yellow. Oh, my banana peel fell. Oh, yes. And SDA? I'm a beast. Great. No. what are we gonna do? Now that we've soldered it, we take the cap, which has some cable slack. Oh, I forgot to remove the custom supports. Let's do it right now. I should have done it before soldering the NPU. How do you remove them? Nice question. You get the pliers, no, the cutters. I will show better in the digital model with all the parts. You just bend them. Okay, this is the custom supports, and they are between this upper part and the lower part. So when it's done, obviously be careful at the compliant mechanism. And the cables, the 0.1 millimeters cables. Done. So now it works perfectly. And let's insert nice. It's inserted. Let's try and move it. Yep, works great. No cable interfering. Nice. Now, these 2.1 cables that we've put in, the heat shrinks, need to be treated. Like this. Now, let's wait for the base to cool down because it's squishy right now. Five hours. At least I think in 3 hours I can finish it. Damn, that's not easy. Let's see, are there people actually mentioning it? 2. That's fine. That's fine. We can chill a bit. I think streaming in the morning it's way better for my audience. Everyone went to bed a few hours ago. Might be a good idea, but still, I have a job. Not yet. Tomorrow I will, probably. I have no way to stream it in the morning. See? Yep. It cooled down. Oh, SCL and SDA will be routed. You can remember having the USB port towards me, towards yourself. The SCL and SDA cables will go to the right. So, USB facing toward you. You, let's say, cable manage them to the right. Okay. And let's glue the heat shrink the parts, because obviously the 0.1 copper wires are pretty fragile, so the less they move, the better it is. The less they are yanked, the better it is. Oh, did I finish my glue? Yep, I did finish my... Oh no, okay, but I'm closed. Now, how many wires do I need on the base? one ground that goes to the Arduino, one power that goes to Arduino, and it should be it. Let's see. "13 cables.
Perfect.
Perfect. There are 11 cables. And we need 2 more for power and ground. And we're done. We're done on the base. Okay. Another thing to remember, so many things. The ground pin and the power pin are both on the left. If you have the USB-C port towards you, will need to be from here up. Ground. Man. I can actually feel the tiredness getting to me. Less patience. Okay, so one power. Right. And for the base should be on. Nice. So the base is done. What's my phone charge? 59%. Yeah. Let's do that again. So we connect to no. Let's connect the phone again. Okay. We're back. Okay, so this is the new workplace. Right. And if you need something, you can show it closer. Great. Now, let's move out away some things. We are missing to implement the Arduino the Arduino, the magnetometer, and that's it. That should be it. Okay, so we've got the base. Whew. That was a lot. If I was 40, man, it's not easy. Still easier than creating the entire mouse. No. The base. What color will I be doing for the base? Black. Okay. Now, this won't be an easy step. So, what's the order of it? Move this aside. Take the base. Take the magnetometer. And we will glue it here. The straighter it is, the better it is. And from the start of the live, from the first hour of the live, not start, remember the epsilon goes in the direction of the south. Which means epsilon goes in the opposite direction of the USB-C port. Is it right? It's wrong. Oh no, it's right. Ah, okay. Now, where is exactly the magnetometer inside of this thing? Let's get close. It's this one. Which means it has to be centered almost perfectly. And it is important for it to be centered. I should have made a tiny template on the base, but I haven't. And with the last drop of glue that we have, we glue it. Come on. So I've tried to be precise, and it should be fine. As a reference, I used this part and this part. Combining them, I should get at the center of it. Yep. Wait. Now, remember that we've done this. I've done one mistake. I haven't checked whether the pins are like this or like this, starting with the upper one, VCC. So let's take another magnetometer and look at it. Oh, I don't need to. There you go. So the first one, it's which means sorry, this one is power. So with the X pointing up and epsilon pointing to the left, the upper pin is power. Then we've got ground, SCL and STA. Now, we are left with 4 wires. We don't need the full extent of them. So we just cut it in half. Let's splice them. Okay. So why did I glue the magnetometer first? So I can glue it flush to the base. Nice. Understand? Ground pin connected. 2 more to go. Okay. So we soldered the 4 pins. If you intend to add the weights inside with a conductive material, add this. Just glue it over so nothing touches the circuits. Man. 6 hours. Damn. I will do it in one life. That's a lot. No. Let me see the phone. Perfect. So, last part. We need to wire in this part. So we can just close it and it's done. Obviously soldered and it's done. Now there is an order on what wire goes where, because inside of the base we've got holes. Now I will copy this template that I broke not on purpose some days ago. Let's start with the magnetometer. We've got first, which should be power, and it goes inside the third if you glued it in the same direction that I did, the power pin goes to these holes in the third one, starting from the USB-C. Then the ground wire goes in the first hole on the other side. The SCL, is it SCL? Should be. Yeah. Goes into the fifth hole on the side of the ground. And the SDA goes in the third hole on the ground side. hungry. I'm tired. One moment of pause. And this one should be done. Next, take the base, USB-C port pointing yourself, base accordingly to the holes of the M3 threads. Yep. And let's copy this one. We've got the ground pin that you connected to the big copper wire, which in this case is this green wire, goes in the first hole on the left. Goes in the second hole. So on this one, then the power cable that we've connected goes to the fourth. Now the fifth hole is the first button on the base. Okay, the next one is the second button on the base. Next to the cable we've connected. Next is the button that comes out from the knob, which is connected to the second resistor. The next one is the cable from the LED ring. I will draw a template for this. Okay. And the last one is the third wire on the base. First, second, third. Now let's go on the other side. We've got the first one that we connected, which is the ground. Then, okay. Now, on the Arduino, we've got the pin 2 and 3, which are SDA and SCL, respectively. But I need to make sure. And here. There you go. I've got a template as well for the holes. And the pin 3, it's SCL, and 2, it's SDA, which means let's start with SDA. That will go to the pin number 2. Yes, SDA, which is in our case orange from the gyroscope. Okay, SCL and SDA are done. Now Going up, we've got the first, yep, the first resistor. This resistor here, the first one obviously with this pointing at you, the first one goes into the, counting from down, 1 2 3 4 5 6th hole. Then the next one is the next resistor. The next is the most left button. And the last one should be the fourth button, and the second counting from the right. And this should be all of them. Do we double check them? Nah. Nah. I never make mistakes. Let's pull all of them enough so we can close the mouse. The more you can pull on them, the better it is. Okay, the other side. Okay, so something to note is that the resin part, once it's heated, it doesn't shrink again, which is bigger. It has too much space, but hey, that's fine. You will never use the resin one. Let's only two, just to keep it in place. And we've got a lot of wires coming out. Whew. Okay, we can finish it. We can finish it. We don't need no more cables. The last step is to solder the Arduino and flash the program. Let's take the USB-C extension that I'm not finding. Let's clean a bit, just to see what the actual is the USB-C extension. There you are. Okay, before doing this, one important step is having all the wires coming out the same length, except from the 4 from the magnetometer, which are the always having the USB-C pointing to you. The first will not count, the third and the fifth. and the first, no, the second. Okay, so we take all of the other cables, we make sure the tightest one. Okay, so in my case I've got about this much of slack before getting to the first cables that are not long enough. So what do we do? It's in front of me. I know it's in front of me, but I cannot see it. What the fuck? I knew it. Just cut all of them. And now this will be the length of the internal wires. Oh, damn. That's not an easy live. My first ever live, 8 hours of building one of the hardest things that I ever created. And smart. Insert the USB extension. Not all the way in. Separate the wires. Nope. Let's go back. We just solder everything up here. So we take our helping hands. And there you go. Now well, I hope I have enough wire because it's almost finished and I don't have any more here, at least. Imagine going through all of this and not having solder wire. Okay, so we need to be precise. No waste. Just perfect soldering. Okay. Oh yeah. get a piece of the 0.6mm wires. And send it through the ground and the pin numbered A3. So I'll show you. A3. Oops. Like this. You cannot see it. So what have I done? There. I've connected the pin A3 and ground, and I'm going to solder right now only the A3, not the ground. Now, take the first wire, obviously the USB-C pointing toward you. Take the first wire, which is on the second slot, the first is empty. Splice it. And send it inside the ground pin together with the copper wire and solder it. Why? I wish I had the energy to explain it. Let's say that if you don't do this, the buttons will not work, every one of them, because this pin needs to be connected to ground. Now, yep, it's done. And let's take the cable that we just soldered and insert it inside the most we can, just to keep it organized. Fucking wire, just go in. It's enough. Next, the power cables. Okay, now, so we soldered the other part of the copper wire. Bend it a bit. Do not make it touch the components inside of the Arduino. Just bend it a bit. So we can solder the VCC pins. Fuck, it bent. Let's take the next two pins, cables, and insert them inside the power. Dude, I really hope this mouse works first try. Imagine. Insert both of them in the power pin. And test space. How I do? Probably. Yeah. Obviously. Do the same. Okay, I don't have the patience to do it because I'm tired. Let's try stronger. Alright, it's not going to work. Okay, we will do it later. Next, the next wire gets soldered to the pin A2. How do I do this? Okay, stay in position, stay in position. Nice. A2, A3. A2, A1. Yep, A1.
Perfect.
Okay. A0. Pin 14. And pin 10. And pin 10. Great. I only need the last right part and I'm done. I just say two more things while flashing the software. Hopefully it fucking works. First try and it's done. Next. Because it's ground. I'm starting on the right part of the Arduino from the bottom, and the first one to solder is ground. The second and the third cable goes to the pin number 2. So it's this one and this one. Okay, let's hope the remainder of this wire is enough. Okay, so the first now the next two will connect to the pin 3 on the Arduino. It's not easy to put them both inside one pin. Still, we'll do it. Are they both connected? Okay, now the next cable goes to the pin number 4 inside of the Arduino. One thing to remember, I told you probably this phrase 70 times. The pins that I'm soldering on the Arduino need to be the same that you are soldering to. Unless you want to learn the hardest way, everything that I had to learn to make this mouse, which I did in the same way. Fuck around and find out. It's the slowest way possible. And the hardest at the same time. Like reverse engineering. I do not recommend it to you, but if you want to do it, good luck. Next, pin number 6. Then pin number 8 and number 9, and you're done. Yep. Pin 8. This wasn't an easy journey. Last one. Fuck. Stay in. Well, we've done soldering. How much do we have left? This is the wire that I've got left to solder, in case I messed up something. Let's put it here. Let's move this aside, because this is an important moment. Move this aside, this as well. We don't need you anymore. Not you. We might need you. We don't need the helping hands anymore. We need you. Let's spin a bit. Now, let's see. Is there actually someone seeing me finishing them? Nope. I'm alone. We need to put this one like this, with a bit of brute force. Oh, no, before doing that, do we want to test if it works? Yes, the answer is yes. So, let's take a USB-C cable. It lights up, at least. Let's move to this view. Let's open VS Code. Damn, I don't have keyboard right. Let's open VS Code. Let's remove this. Now, let me see what are you seeing? Okay, COM9. I will just flash it just to see if it works. Then I will put it inside and tell you what you need to know for the code to work. Please, am I looking at myself? Yeah. Here, please. What was the error? Oh, okay. My bad. Please, after 6 hours. Please. The upload went well. It lights up. Can you see that it lights up? No. Look. That's light. Okay. Let's go back here. Well, let me see a bit of the code. Do we have something to print? Yeah, these two should be printed. Let's try again, probably. Oh. Let's see if the program from 3D connection recognizes. Oh, okay. Okay, so let's insert it and let's cry later. Now let's come back to this. With a bit of brute force, we will insert the Arduino. Let's straighten up every soldering that we've done. Great. Now shorten the cables. Back, why is it smart? Don't be too aggressive. I am being aggressive. Great. Let's take the USB extension, insert it, so now we can take this off and look inside. Now we had some problems connecting it. So, oh, someone typed, I can't watch online, I'll be happy to watch the record if it's on the channel, I'm interested, good luck. Yeah, it will be on the channel. Nice to see you doing projects, best of luck. Thank you HBAM and thank you Sergey. I will also take the parts of the live and make a video for the people that do not want to look at the 7-hour live to build this mouse. And right now, since one of the two sensors it's not working, we use the multimeter to check if the connections at least are there. So I can show you how to look for problems, because you will have problems while making one. Let's start with seeing, is the power connected for both of them? It's not. What? It is. It's flaky, probably. Okay, so something that I can do is probably resolder the VCC groundworks, SCL works, and SDA works. So in my case it's probably the pin VCC. Let's go back here. These wires are really... Why did I choose? Why did I fucking choose to make it harder? Now, let's insert it again. Yep, move it. Perfect. Let's solder again the VCC pin. Usually the problems are there. If nothing shows in the terminal, it's because one of the two sensors is not working properly. So okay, let's take them off. Okay, let's try again. Lights up. At least that's a good sign. Let's switch your views. It shows the project as the costly mouse. It doesn't show anything. Let's see. Does it have light? Oh, it doesn't have light. Do you? Yeah, so the gyroscope works. How about the magnetometer?
Perfect.
We haven't solved anything. Oops, that's fine. Now, magnetometer again. Could it be that they are... Oh, let's swap your views so you can see what I'm doing. I think that probably the magnetometer has two pins connected. Imagine if I got the QMC and not HMC magnetometer. It might be. We will check if this does not work. We will desolder it and solder an HMC mouse that I'm sure Okay, so the plan is desolder this HMC that I got from Amazon, desolder this HMC that I got from AliExpress, and let's see. Oof. I do have enough solder. and let's resolder it, and let's see if the problem solves itself. Oh shit. I think it's not going to work after this. Imagine. Let's. Oh, that should be soldered right. Let's try and solder them properly again, and let's see if something changes. From the back as well. Let's try again. We can't do much, so we can just solder, try, solder. Let's first see if the power pin is connected to the power on the Arduino. Yep, ground. Yep. SCL. And SDA. Well, let's try again, because the connections look to be working. It's so nice, the frost. It's not working. Well. Let's try one more time to see the pins on the gyroscope, just to be sure. working. Ground. SCL. STA. Yep. So the only thing I can do cut off this glitch. And let's try this HMC and let's see if that's the problem, because if that's the problem, do not buy them from AliExpress, even though they are way cheaper. Okay, so let's desolder them. Great. Now let's splice them. Oops. No. So we've got, let's prime these pieces. Okay, need to be meticulous, I don't have much more solder. Let's just solder in it. Fuck, 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 fuck. Yeah. Pum, 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 pum. We need more priming. sort. Okay. Now okay. The new magnetometer is soldered. So what are we gonna do now? You just connect it. Let's switch. Or if it doesn't work again. Please. At least that part works. It doesn't work. So the problem is the gyroscope. Somehow. Did I just see a green light? For a moment. Oh, I found the problem. It's the gyroscope. Some of the wires are not separated from each other. And how do I know this? Let me show you. The light off on the gyro, if it disappears, see? Well, it does disappear sometimes. So let's try. So, still, it's the gyro. Good news. Looks like this pin right here the ground and the VCC are not working properly. So let's just cut them and resolder them. So what's my solution right now? Seven hours and a half. Yeah, that's great. Okay. I will get these two wires, VCC and ground. Let's swap these two wires. Two regular wires. Why? Because I know it works with these point wires, but I don't have the energy right now to resolder that. So what do? We take the jumper wires, we solder them directly. Let's prime. How much solder wire do we have left? Where is it? Where is it? Okay, so the problem wasn't about magnetometer, good. At least. VCC. So this is it. And ground. So put it back in. Fuck, which one was... I don't remember. I can watch it back. Can I? Yeah, I can watch back the live. Okay, the purple is the VCC. This is power and now the ground. Let's prime it because I haven't done it in a while. Okay. Now, let's try again. So, at least it lights up. Damn. I don't need more, so I can just... Let's see if now it works. But if it doesn't, I don't know. Oh, there is no com line. Wrong button. Let's try again. Okay, so the thing is, nothing. Now, last chance we've got. I don't have the energy to do that. So, what am I gonna do? No, I still got time. I can do this. I can do this. I can fucking do this. Let's rewire the SCL and SDA pin on the gyroscope. Let's take these two off. Oh. And what are we gonna do? We are going to take these two wires, let's remove them. Take these two, which were the pin number 2. So I can get you. Yellow MPU, yellow SCL, orange SDA. So yellow SCL. So we take this one. Let's take a different color, just so it's easier on us. Oh, yes, not bad actually. We can do this. I can do this actually, all by myself. But I need to finish it.
Perfect.
Now Okay, we don't have many more chances at this. That's my last solder. Right? Another test. It's not working again. Yeah. At least the program recognizes the mouse. Do I need to be real? I have no fucking clue. Okay. So I think these two are connected properly. I don't get it why it's not working. But still, if nothing shows, it's the sensors. Unless the Arduino is the problem. But highly unlikely. Okay, so this work. Alright. So what's the next thing I'm gonna do? I can show you how a proper mouse works. This is my mouse, the first one I've made. It shows the buttons. If I press them, like the button 0 is the circle, and yeah, and all of them. So this is what you should see once the sensor work. That's it. Why is it not working? For real? I don't fucking... And I'm tired. And I wish I had the energy to fix it right now, but I don't. And that's the reality of it. Everything is connected. So what am I gonna do? Trying to think. Thought, what a shame, what a shame. Can I try again? Let's try again. So, if as an example, the wires let's see, more troubleshooting. If the pins ground and VCC were going to touch, the mouse shuts down. So that's not a problem. If SCL and SDA touch, nothing happens. So, in the probability that let's try connecting a working mouse, make it transparent. And the output works. And if we touch 2 and 3, it stops. Great. So we know where to look. Are these two connected? They look like connected. Okay, that's interesting. So, once again, SCL It's not beeping, what? Maybe found a problem. Yellow SCL. Probably I inverted SCL and SDA on the Arduino. So we've got first SCL. Oh, I probably didn't. Okay, that's good. So let's search online the Arduino Pro Micro pinout. 1 second. Probably should have worked from the start. So the pin number 2, it's SDA. So orange, 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 white, white. So that's not the problem. But why are they not beeping? Are they not connected inside the Arduino? I might have a solution. So the only thing that comes up in my mind is that I did not connect properly on the Arduino part. And as a check again, it does give me a signal if I connect SCL and SDA. Should it give me something if I connect them? Yes. And with the magnetometer, SCL. Nope, they are connected properly. It lights up as it should. Look, everything is in order. Since no one is looking at live, I could even pretend that it's working, but I'm not. Hey, hey, hey Algot. You came just at the end of the live, where I'm not realizing why it's not working when everything should work. At least I've got working mouses I can show on the code. But I'm trying to figure out why this one is not outputting. It's not. It's not. It's not doing what it should do. Well, so that's the plan. We will build another one on another live, but as of right now, we are going to connect this mouse. We go on screen share. We are going to add another video device capture. Okay, let's take down the light for this. Yep. And now the code. Once you plug it in and upload the project, first, before uploading the project, you need these libraries on your computer. If you understand just a bit of programming, you know that you need these libraries. And what do I mean by you need libraries? Search it online. Go on Arduino IDE, install the libraries. I am using VS Code, you don't need to. Use Arduino IDE, install these libraries, input the software, the firmware, and once you connect it and you have the 3D connection space mouse, original, the 3D connection program, open. It should say that you have connected this type of mouse. So you have all kind of things that you can modify. And does it work? Oh, wait. Close the serial port. Maybe the problem is not me. There might be something else. Let me see. That's weird. Now nothing is working. Please, what the fuck? Now it does. Now it doesn't? What? My computer is... I don't fucking know. But let me see if you can see it properly. So let's do this. Reboot it. Show the mouse. If you touch it and it becomes green, it means it's working. And you can just move inside of the model. Now the north on my side is on the left because I don't have a longer enough cable. Let's see. Or perfectly works as it should be. Now, what the fuck is wrong with this one? Working perfectly fine. And when I stop monitoring, yeah, probably the computer, it's by my computer side. Okay. That's not much more to say. That's the code. If you know how to read it, you can. It's not hard because I made it. And that's it. I'm sorry, Algot, you came late. And the live is done. Man, 8 hours. And it doesn't work. Still, the focus of this project is the compliant mechanism, which works great, easy to make. I will cut the parts and make it in a shorter video so anyone can build it. Let's make myself bigger and remove this. And yeah, that's it. I've said everything that I should have said. Yeah, I promise the project works. And I've told you, it's an hard project. And probably making one in 1 day is a lot. And yeah, remember that I make stuff so you can too. Bye.